Okay, so let's move to chapter 3. Chapter 3 is number series. Talking about the number. So usually this number is integers. So for integers, like there's two, those integers like 12, we can factor the 12 as 2 times 2 times 3, right? So those 2 and 3 cannot be factored anymore. So we call those as prime number, and we call those as we just write an integer as a product of prime numbers, or we also call those a factor. Okay, so now let's consider the factor this number. So we just check out this number. So we say we want to find this. So we just check this number, whether this number have this factors, those prime, those factors like 2. We usually check 2, 3, 5, 7. So we call those are prime numbers, right? So we find 5 is okay, right? 5 is the factor of this number. So here 4, 9. Okay, so 4, 9. So we just check 7. So we find this. So we say this number can be factored as 5 times 7 squared. So when we wanted to simplify fraction or to reduce form, we just needed to factoring, right? Cancel as much as we can. So let's say that here we just factor. Let's say so 3, 1, 2, 6, 1. We find 2 is the divisor of factor. Okay. Then this number is still even number, so we have 2 as factor. So 7, 8. 7, 8. Still we can divide by 2, right? Then 39. And 39 we can divide by 3, so 1, 3. So okay, so we can say like okay, so this number, so 3, 12, we can factor like 2, 3 times 3 times 13. And so let's do the same for 360. So 360 we also can factor this way, because 36 is 6 square. So 6 square multiply 10. So 6 square, 6 is 2 times 3. So 2 square, 3 square, and 10. We also can factor 10 as 2 times 5. Okay, so 360 can be written as 2, 3, 3, 2, and 5, right? Okay, so we cancel this, or cancel this 3. Okay, so reduced form is 13 over 15. Okay, so for this number, for this problem, we say like 250 for this number. They have many factors. Or we just check of many. So we check prime factors. So at the first level, we say 250. 250 can be written as 25 times 10, right? 25 times 10, and 10 also can be factored as 2 times 5. Okay, so this equals to 2 times 5, 3. Okay, so prime factor can be 2, 5. So just only the 2 prime factors. Okay. So this problem says x and y are two smallest positive integers, for which the product of the 360 and x, 360 multiplied by x and x is a square, some number square, and 360 multiply y is a cube, like this. So we have many such x and y. So here we just check the smallest x, y. Okay, so for this problem we want to factor 360. So we know 360 equal 2, 3, 2, 3, and 3, 2, and 5. 360. Let's say 360. We already just check this. 360 equals 6 square, right? 6 square multiplied 10. So equal 2 square, 3 square, and 2, 5. Yeah. So 2, 3, and 3, 2, 5. So we have this number multiply this x equal, say some number square, and 2, 3, 3, 2, 5 multiply y is some a number 3. So from here we can find x should, so we have 2, 3, so x should at least 2, one more 2, right? So 3, 2, it's okay. Then 5, 1, so we need one more 5, 5. So smallest x is just 10. So for y, 2, 3 is okay. So 3, 2, so we need one more 3. And 5, so we want at least need 5, 2, right? To make a cube. So this y just equals this. 3 times 5 squared, 75. So we say smallest x is 10, smallest y is 75. Okay, this is the z is a 6-digit positive integer, such as first 3 digits, first 3 digits and the last 3 digits are same. Okay, so in general we can say like this z can be equal like x, y, z, x, y, z, right? Okay, so this number we can write like x, y, z, this number multiply 1000. And x, y, z. So we can write this as x, y, z multiply 1001. So this x, y, z can be any number. So the question is like, which of the following number must also be a factor of z. So we just check which number is a factor of 1001. So we find, so we just check how about 11? 11 is okay. So we find 999. Okay. Oh, so we find 11 is okay. So we say this one is okay. Okay. So this is the sum of two prime numbers is 85. So there's two prime number, like there's two prime a plus b equal 85. So here we have two unknown variables like a and b, but only one equation. So we cannot solve it, it seems. But here the keyword is prime number. Prime number. Okay, so we know prime numbers, those are prime number. 2, 3, 5, 7, and 11. So those prime number. So we find, so those prime number, all those prime numbers are odd numbers, except 2. 2 is even number, right? So this process is odd. So meaning like 1 is even, 1 is odd. If odd plus odd is even, so we say this a should be equal to, saying this should be 83. Okay, so 83 is this is also a prime number. We say yes. Okay, so those are two numbers, just 2 times 2 and 83. Okay, so what is the product of these two numbers? Easy, right? 2 times 83. So should be that 6, this one, right? Okay, so for this problem, what is the sum of the distinct prime divisor, integer divisor? So here the keyword is prime. Okay, so at the first we just try find the prime factor or divisor of this. So let's say 2016. So we want to factor this number. So at the first we say 2, and this is also even number. So divide by 2, 5 or 4. Even, okay, this is 2, 5, 2, still even, okay, still even, okay, so let's say this 1, 2, 6, or still even, so 6, 3, so the 3 we continue, so the 3 can divide by 3, 21. 21 can be divided by 3 and 7. Okay, so finally we get this. We factor this 2016 as 2, 1, 2, 3, 4, 5, 2 5's power, and 3, 2, and 7. Okay. Okay. So its prime integer divisor is 2, 3, 7. So only this, and 2, 3, 7. Only these 3 prime divisors, right? Yeah. Okay. So now let's say for this number, we want to find the smallest or largest divisor. So for such a problem, let's say 20116. At first, we need factors as 2, 5, 3, 2, and 7. Okay. Okay. So smallest, we just find the 3 smallest divisor. So smallest could be 2, 3, and 6, like 2 times 3, and 7. So those are smallest. So largest divisor, we just divide by 1. So largest, this is divided by 1. Then divide by 2. Divided by 2. And divide by 3. Let's see. Divided by 3 is divided by 3. Divided by 3 is 6, 7, 2. So those numbers are largest 3 divisor. Okay, so here we're talking about for a given number how many factors this number has. Like 12, 12. For this number, how many factors this 12 has? So we can have 1, right? Could it be 2? So could it be 3? Could it be 4? Could it be 6? And 12. So we say number of fact of this 12, this number we have 6. Okay. So for small numbers, we can list all its divisors, so we can count how many. But in general, we try find a formula, find a way, right? For a given number, we want to find how many factors does it have. So we have this result. So if this number can be factored as this, like P1, this is prime number, K1's power, then P2's K2, then we have so many. Just K1 plus 1 times K2 plus 2, like that. Okay, so now let's go back to here. Like how can we find the 6? So we say 12, so we can factor the 12 as 2 times 3, 1, right? 3. So we find how many factors it has. So we say that 2 plus 1 multiply 1 plus 1, so which is 6, right? So this is just confirm like this formula is true. Okay, so now for some big number like n equal 12,000, so we need at first we need to factor this number. 12,000 is equal to 12 times 100 10 square. So equal 12 is 2 square multiply 3, 1, this is 12. 10 is 2, 5. Okay, so put it together. We say equal 2, 4, 3, 1, 5, 2. Okay, so how many factors this big number, this number has? So this equal just 4 plus 1 multiply 1 plus 1 multiply 2 plus 1. So equal 5 times 2 times 3. So equal 30. So we can say this number has 30 factors. Okay. So we have, if a number is big, then it could have many factors. Okay. Okay. So for this problem, this is like a group of students. So we don't know how many. Suppose we have n students. Okay, so for those students, we can let's say this story is just like that. Like we have so many students, so we can arrange those students like stand in a row. So let's check. Let's check. Let's say, suppose we just have 10 students. Okay, small number. So we can ask those students stand one line, like this way, or this way. Okay, also can be like this way. Five students in a row, or in this way, 2 students in a row. Right? So if we have 10 students, we can only arrange them this way. So we guarantee like each row or each row has the same number. All the rows have the same number of students. Okay, so the problem just says like on June 1st, they are standing in a row with 15 students in each. So 15, 15, 15, 15, 15. So how many 15s? So we don't know, right? So we say, so here we can say like this n, suppose this not, so suppose this n is those students. So we say at the first level, n should be equal 15 times some integer, right? Okay. So on June 2nd, June 2, the same group is standing with all the students in one long row. So just this, right? So n equal some number 1 multiply a. Yeah, so this is okay. So in June 3, the same group is standing with just 1 student in each row, just like that, like just like that, like one, first round, second round. Okay. So here, doesn't matter like how many students, always can do that. Okay. So in June 4, the same group is standing with 6 students in each row. So this also means n equals 6 times k, right? So those k not the same, so we put it as k1, k2. So n is multiple of 6. So this process continues through June 12 with a different number of students per row each day. Okay, so this means that n, we say this n has 12 factors. Okay, so on June 13 cannot do that. So this means that this number has 12 different factors. So what is A? So we say we have many possible ways. So if we want to get it, this n has 12 factors. So this n can be, let's say, 12 can be 12. Let's say 12 can be equal 4 times 3, or can be 2 times 2 times 3, right? So if there's 4 times 3, so n can be p1, 3 times p2, 2. Okay, so if n equal p1, 3 times p2 is 2, then the n has 12 factors, right? Or n can be like p1, 1, p2, 1, p3, 2. So if n equal p1, 1, p2, 1, p3, 1, then this n also has 12 factors. So we just check smallest, because we have so many such numbers. So here we check the smallest. Okay, so smallest, so in this case smallest, so smallest, we just check the smallest prime numbers. So let's check this. That's like this can be like 2, 3. So this is 3, 2. Or we can be like, how about this, 3, 3, 3, and 2, 2. Okay, and for this one, maybe we can say this is like a 2 times 3 times 5 square. We just pick a smaller one, 2, 2, 3. Or maybe we can pick this square as 2, 2 square, and here this is 3, this is 5. So we just check which number, which one is smallest. Which number is smallest? Let's see. So here we need to compare those numbers. Let's say, calculate it a little bit. Okay, so I think this one is smallest, right? This is 60, yeah. So all other numbers are larger than 60. So 60 is the smallest number. Okay. So this problem is we want to find a number A. We only know like this number has so many factors. So we want to find all like such possible numbers. Then we just pick a smaller one, smallest one. Okay. 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 So we can stop here. Then we will continue. Okay.